Hello everyone. In this video, I'm going to talk about Proc Sql Joins. So, Proc Sql procedure is simple, flexible tool for joining tables of data together. So there are different kinds of join that you can do. You can merge the data different way. So I will give you a brief idea about what are the different types of the joining or merging of the data sets. So first one is one-to-one merge. In this situation, each value of common variable in first data set, second data set has only one matching value of that common variable ID. So this is an example or the situations where a data set has a common variable ID which is present in the both the data set, and if you see the value, so only one value is available in the data set 1, and matching value in the data set 2 is also present only once. So in the likewise, the second value is also present only once in the second data set. So likewise, this is an schematic. You can see that how the common variables are present and only once in data set 1, and as well as matching value are present only once in second data set as well. So that kind of merge is called as one-to-one merge or one-to-one join. The second situation is like when the value of common variables in first data set is present only once, but in the other data set it has more than one matching values of that common variable. So this is the situation here. If you see, the data set 1 has a common variable ID which is present in both the data set, and these are the value of that variable. So you can see that this value is present only once in data set 1 but present twice in the data set 2. So likewise, whatever the value is present of this common variable in data set 1, there is a possibility that only one or more than one values can be present in the data set 2. So this is the real situation. You can see the schematic about one-to-many relationship. So this is a situation where we can call one-to-many relationship or one-to-many join of the data set. So third one is many-to-many relationship. In this situation, when both the data sets has multiple entries or multiple values for this same common variable, then it is called many-to-many relationship. So this is a schematic presentation. You can see that these values are coming more than once and in both the data sets. So this is a data set 1, this is data set 2, and in the real scenario you can see the data set has the common variable ID which has value more than once present, and also more than once present in the data set 2. So in that situation, we called many-to-many relationship or many-to-many joins. So just wanted to give an emphasis here that Proc Sql handle many-to-many joins much better way when you compare with the DATASTEP language. So that is an advantage of Proc Sql joining. So I will give you an example with more details and later on in this video. So there are different kinds of joining is possible. In Proc Sql, you can do inner join where you can find the common matching variables in two different data set and extract that. You can do left join where you can take all the values from the left table and matching from the right table. You can do right join where you can use all the values from the right table and only the matching values from the left table. And you can do the full join where all the values are combined together. You can do further conditioning as well other than this to extract different kind of the data as well. So this is left join, and this is the right join, this is the inner join, this is the full join. But if you will use where statement, you can further provide the conditions and exclude some of the values from your by variables or from common variables. For example, if you are using where b key is null, so that means you are taking only the value of the left table and excluding the value of the right table, and you are also excluding those who are matching with the right table. So that kind of condition you can provide, and you can extract table based on your requirement. So moving ahead, I just wanted to give you few important points. There are certain advantages of Proc Sql joins over DATASTEP merging. So the first advantage is Proc Sql joins do not require sort table or sort datasets. So that is one of the biggest advantage. And Proc Sql joins do not require that common variable have the same name in the datasets. So suppose I was talking about the ID common variable. So if in the second dataset that name is different other than ID, still you can use Proc Sql join and you can merge your data. So that is also an advantage. The third advantage is that Proc Sql joins can use comparison operators other than equal sign. So that is also an advantage. As I showed you in my previous slide, here we are using is null. We are not using an equal to missing or something like that. So that is an advantage of Proc Sql. And the biggest advantage of Proc Sql is that it handle many-to-many relationship or many-to-many merge well, whereas the DATASTEP program doesn't work well when you will use many-to-many merging of your data sets. So these are the very few points that you have to remember. Show you that how it works actually, what kind of different joins that you can perform using Proc Sql. So I will start with cross join or Cartesian join. So Cartesian joins, where the Cartesian's product, you can see the final result return a number of rows equal to the product of all rows. So for example, if you have a data set which has 10 rows or 10 observations, and the second data set also has 10 observation or 10 rows. So the merged data set will come with 100 rows, which is equal to 10 multiplied by 10. So that means each observations from the first data set is now merging with each observation of the second data set. How it works actually, so I will show you with an example here. This is a first data set, which is maths data set, and it has two variables and 5 observation here, you can say. And this is second data set, physics data set, which has also two variables and 5 observations. So when you will do Cartesian join, what will happen? So we have here a common variable ID, you can see that. So in Cartesian join, what will happen? First observation from the first data set merge with each observation of second data set. So the first observation, this one, will merge with this one, and then this one, and then this one, and this one, and then this one, likewise. So it will give you 5 output or 5 product when it will join or when it will merge. So likewise, the second observation also merge with each observation of second data set. So it will again merge with this one, this one, this one, this one, and this one. So third will also merge likewise, fourth, fifth, and ultimately a 25 observation or rows will be generated because of merging. So I will show you how it works and how the syntax you can write about the Cartesian join. So syntax is very simple here. You have to start your programming with the Proc Sql as I explained you, and you have to end your programming with the quit statement as I told you earlier. And because I'm going to create a table named xjoin, you can give any name as you want. I'm giving just for simple uh, to keep it simple. And you have to write select statement, and I'm selecting all the variables from the dataset maths. So that's why I'm selecting asterisk. Asterisk will as explained earlier, it will select all the variables from the data set. and from maths data. So I'm selecting all the variables from the maths data, and you have to write cross join, keyword to perform the Cartesian join. And at the end, you have to provide the name of your second data set by which you are doing Cartesian join. And ultimately, you have to give a semicolon at the end, and then you have to complete your program with quit statement. So I'm running both of these. First I will run these two tables, and I will show you that how the outcome is coming. So you can see that this is maths data, two variables, 5 observation, physics data, two variables and 5 observations. And when I will run this program, it will give you a Cartesian join. So you can see that the output will come with 25 observations. So this is, the table generated work x underscore join, and there are 25 observation here. So the first ID has merged with each one of the second, then second ID, and third and fourth likewise. And ultimately the output is whatever the observation in the first multiply with the number of the observation in second. So but you can see that there is a log issue is coming here. You can see warning sign, variable ID already exists on work for on file work dot x underscore join. So this warning you can address and you can fix it. I just wanted to show you that how you can handle this warning. So there are different way that you can handle this warning sign. So first of all, instead of mentioning all the variable, because when you are not defining your data set here, so it will merge all the variables from both of them, both the data set. So what I'm going to do that I'm going to define from which data set I am taking all variable, and from where I'm not taking all the variables. So from maths data set I am taking all of them, and I'm writing comma, and from the second data sets, which is physics datasets, and I'm taking only this variable because ID variables is already existed, and now you can see that I just completed it, and when you will run this program, it will show you no error actually at the end. You can see 25 observations are coming out of join, and we addressed our log warning, and no any warning is coming now, that you can see that. So this is one way of addressing the warning about the repetitions of the variables. The other way you can do that, like instead of writing the name of the dataset, you can write X for dataset maths, and Y you can write for the dataset physics, and you can define that what X and Y means. So here you can define that from maths you can define as X, and you can join here, and you can write here as Y. So here you are defining maths data as a X and physics data as a Y, and you are referring that X and Y, that you are taking all variables from X and you are taking only physics score from variable Y, which is actually physics. So when you will run this program, it will give you the same output with the Cartesian join, which is 25 observation out of this joining. So this is very important function that you can use in Proc Sql programming. So now coming to full join. So Proc Sql has an ability to do the full join where all the rows and observations from the left data set will merge with all the observations from the right data sets, or second data set you can say. So I'm using the same example here. We have a data set maths which has two variables and 5 observation, and second data set which is physics also has 5 different observation and two variables, and you can see that ID variable is common here. So when you wanted to join these two tables in full join, in the DATASTEP program you have to sort your data. For example, you have to sort your maths data by your common variables, which is id here. You have to sort your second data, and then you have to write the merge statement here, like you have to create your data set here, and you have to write merge statement, and you have to write also the by statement, by which you have to mention the name of the sorted variables that you used earlier for sorting your data set, and then you will get the merged data set. So I'm going to run. So this is based on the DATASTEP program, and after that I will show you how you can do the same thing in Proc Sql Join. So this is the merged data. You can see that this is the ID. This is all the observation from maths data set, and these all the observations from the physics data set. Because these two variables are missing, these because these two ID are missing in the physics data set, and these two ID are missing in the maths data set. So you can see that S1004 and S1005 are missing in the physics data set, and likewise these two values are missing in maths data set. So that's why after merge you are getting some missing values. So but this is when you will use DATASTEP language or DATASTEP program. But how you can do that using Proc Sql? So Proc Sql, you have to use the same steps you have to take as explained earlier. You have to start your program with the Proc Sql statement, and after that, and you have to end your program with quit statement. And because I'm creating a table, I have to write a create table statement. You have to write name of the data set that you are creating. You can write any name, A, B, C, D, or whatever you want. So I'm writing join dataset. As alias is needed here, because when you are writing create table, you have to put as here, and after that you have to write select statement. And for now I'm selecting all variables from maths dataset. So you can see that the maths dataset we have here, and I'm selecting all the variables, both id and maths score. And after that I'm doing full join. So this is the keyword you have to write, full join, and I'm doing join with physics dataset. So you have to write the name of the second dataset, and this is the very important. You have to write on and you have to write this statements that id from the maths dataset is equal to the ID of physics dataset. So that is very important when you are doing Proc Sql joining. So you have to remember that you have to write on, and you have to write this statement where you are going to provide the variables which are common and referring to each data sets, and both of them are equal. So when you will run this program, it will do the same job, like it will merge maths data set with physics data set, and it will give you a result. So you can see the merge is completed here, and output is generated as a join data. But you can see that some of the ID values are missing here, and these values are missing. It was also missing in the data step merge as well. And you are also seeing the same problem, the warning sign, that is also coming here. So how you can address? So um, first, I will address the warning sign as I addressed in my previous example. So you have to provide the name of the data sets, and you have to refer uh, the variables. So I'm taking all the variables from the maths data set, but I'm taking only one variable from the physics data sets. So I'm writing this is the name of data set, and I'm taking this variables only from the second data set. So I'm going to take this one here, and you have to write comma, and then again everything will be the same. When you will run this program, it will give you the same output, but no log issue. But still we have to fix that why this id is variable is missing here. So the reason is that because we are taking maths dataset first, and in maths dataset these two id are not present, and that's why it's missing coming here, and rest of them are same. So how you can fix that, and how it will be fixed so that it will come similar to the data step merge. So for that, you have to do the next step job. So in that case, you have to define that using the callis function to remove the common variables repeat. So for that, you can do the callis statement here. You have to select the name of the data set. So I'm referring X here. X is referring for the maths data set, and Y is referring for the physics data set. So as I explained earlier, so the callis functions pass with these two statement here with x dot id and y dot id, and you can give the name id. You can give another name as well, and after that you can refer to the maths data set, and you can take the maths score variable and the y, which is referring to the physics data set, and you can refer the variable physics score. And again, everything will be the same from maths data set, and here you are defining maths data as a x and physics data as a y. And so again, it's doing the same job, full join, and the same statements that x dot id is equal to y dot id. If you don't want to use x or y, you can use maths, the name of the data set, and instead of y, you can use physics, the name of the data set. Then you don't need to write this statement like as x or as y. So but it will be easy, and you can handle whatever way you want. So when you will run this program, it will solve that issue, and you will get the result that what is coming in the data step merge. So you can see that you are getting all the name of the id, and again two values are missing because it's originally missing from the maths data set, and this is the physics score. Two values are missing because these are the missing in the physics data set. So this is finally a join statements, or proc sql joins with full joins came, and you can, so it's very much similar to what is in the data step programming, where you are using merge and by statement. So now coming back to inner join. So inner join returns rows common in both tables. So for example, in the data set maths and physics, so the common variables id is present in both the data sets are only 1, 2, 3. So these three common variables are present in both the data sets. So when you will do inner join, it will merge only these three records all together. So that is how it works, and I will show you with an example here. Let's run this two programs so that you will have an idea about the maths data set and physics data sets. So as you can see that only common variables id with this value are present in both the data sets, this one and this one, and these are exclusively present in maths dataset and not in physics dataset. These two and these two are present only in physics dataset but not in maths dataset. So when you will do inner joining, you will not get these values because it will return only the common values that are present in the both the data sets. So coming to the program, you can see you have to write everything same as I wrote for the full join, except that you have to write inner join statement here instead of full join. So when you will write inner join, it will give you the value of common variable. So you can see that this is the joining is happen, and you are getting what is common in both the table. And similar way, when you will do the left join, so in left join what will happen, like all the values are in the first data set, which is maths, it will come, and only the matching data set from the second data set will join in your final output. So for example, when you will do left joining, this all 5 records will come, and only the matching these 3 will join here. So I will show you with an example here, the left join. everything is same. You have to write proc SQL statement, and you have to write create table. Select, you have to use coalesce function when you will find any common variables, between two different data sets. And let's run this one, and you will see that the all 5 IDs coming here, but only 3 which are common is joining here, but 2 other where in the physics data set are not joining here because their ID is not present in our left data sets, which is maths. And likewise in the right join, if you are using right join, so all the values, or will from the right table or right data sets will join, and only the matching from the left will join. So the same way, if you are creating with the right join statement, you can see that instead of 4 and 5, 6 and 7 is coming, and these two values are missing, but all the records from the physics data sets is merged here. So this is the way how you can do right joins, left joins, inner joins, and full join. So next thing, like when you are doing any kind of these joins, for example, inner join, left, right, or full join, if your common variable name is different, still you can do the merge. For example, this is the dataset maths where the variable name is ID and maths score. And suppose the second dataset physics, I can change this variable name as identity, instead of ID. So you can see that the name is different here. When I will run this program, we have two different data sets, maths data set and physics data sets. But you can see common variable name is different. In one data set it's identity, and another variable name is ID in first data set. So but still you can do your joining here. So for that, what you have to do, that you have to write the program in the same way if you are doing inner join or full join. So I will change it. So suppose I'm doing full join here, so I will write full data, and again coalesce function. So here you have to define, so X is referring to the maths data set as I'm doing here, and Y is referring to the physics data sets. But in physics data set we don't have ID, we have identity. So you have to change the name of this variable identity as ID, and I wanted to give the new variable name as IDD, so instead of ID. Okay, and when you will change this one, and you have to define here also in the second in the last statement, that x dot id is equal to y dot identity. So this is how, when your variable name are different, but still you can do the joining function. So I'm doing full join, so I have to write full here, and when you will run this program, it will work and it will give the same result here. You can see that. So full join is happen, and it will give you the final data set as an output. So this is very interesting, and this is an advantage that even if you have a different name, still you can join your data with a second data set. And that is one of the biggest advantage of Proc SQL over the data step merge. So finally, coming back to one of the major difference where many to many merge is handled by Proc SQL joining, and how this joining is different than data step merge. So this is one of the major difference, that how data are basically merging and outputs are totally different when you are using data step merge program, or you are using Proc SQL join. So in data step merge doesn't handle this merging very well. When you perform many merge using the Proc SQL, it will give you a Cartesian's product of matching observations. So I will explain you in details that how it works. And for example, if there are 3 records in one contributing table and 2 records in other table, so it will give you a total 6 records. But in data step merge, what will happen, it will not give you the Cartesian product, but it will give you the duplicate value equal to maximum number of duplicate value in both the data table. So this will be more explainable using the real data. So I will show you. So for example, we have data dat1 and dat2. So the name of the data set, and there are two variables, and we have duplicate records in each data. So here common variable id is duplicate. You can see there is a 2 value here, and also id2 is twice. And in the second data set as well, you can see 3 records are there of this id, and likewise 2 records for the id in this data set. So what will happen when you will use merge statement for doing general data step program to merge? It will give you like a maximum number of repeats or duplicate id is 3 for this id 1. So it will give you final output of 3 id in your merge data set. And here, because 2 is here and 2 is also here, so 2 records from id2 and 1 record from id3. So the output will be 3 values with 1 id, 2 values with 2 id, and 1 value with 3 id. So that is in the data step merge. But what will happen in Proc Sql join? So each value will join with each observation from the second data set. So for example, first id of this observation, this observation will first join with this, and then it will join with this, and then it will join with this. So it will give you 3 records. The second id will again join with this, and this. So it will give you total 6 of output when you are using the id1. So, and again, when you are using id2, it will first join with these two, and the second one again join first with this one and this one. So it will give you 4 actually. So 2 multiplied by 2 is 4, and ultimately this will give you 1. So that is the difference. So I will show you in real program that how it will happen. So as I told you, for using merge statement, you have to sort your data and you have to merge it. So when you will run this program, you will see the combined data set has 6 observation, as I told you. So id, we have a 3 records for 1, 2 records for 2, and 1 records for 3. So when you will use Proc Sql join to combine and to look for the many-to-many combination, you have to write this program as I explained earlier. So it will start with Proc Sql and end with the quit statement. I'm creating a table named combine2, and exactly I'm selecting the variable here, from both the data set as I explained, and I'm selecting info from the data 1, which is dat1, and I'm selecting info 2 from data set 2, which name is dat2, and defining as a y. And again, I'm giving the conditions here like x dot id is equal to y dot id. So when you will run this program, it will join both the table in a Cartesian manner. So you can see that 6 records is coming from id1, and 4 records are coming from id2, and 1 record from id3. So this is the right way of combinations, like as I explained you, like each observations from the data set 1 will combine with every observations of that common value, and that's why this output is more acceptable and accurate as compared to the data step merge. And that's why uh, this is an advantage of Proc Sql joining as compared to the data step programming. So I hope you like my this video, and I will request you to please subscribe my channel and like my videos. Thank you very much for watching.